All right, let's formalize the process for solving polynomial inequalities. First thing we're going to want to do is get all the terms to the left side, and that is very important, that left side. We want to have the expression either less than 0 or that expression greater than 0. Okay, once we have that, if it says less than 0, we're looking for intervals that are below the x-axis. If it says greater than 0, we want to find those intervals where the graph is above the x-axis. Of course, if it equals, then we just include the endpoints. All right, so let's look at an example. If I have this x squared minus x minus 5 greater than or equal to x minus 2, move everything to the left, combine our like terms, and we get the quadratic x squared minus 2x minus 3 greater than or equal to 0. I know this is going to be an upward opening parabola, so if I factor it to find the zeros, I should be able to get a quick sketch. Factoring it, x minus 3, x plus 1 tells me my zeros are 3 and negative 1. So real quickly, you can sketch that graph just like that. Opens upward, goes through those zeros. Now what are we looking for? Well, it says we want it to be greater than or equal to 0. So we want the sections on this x-axis that make the picture above the x-axis. So any x back in this side here is going to give me the picture on the upside. Okay, so from negative infinity to negative 1, and I put a bracket to include the endpoint. We don't want these x's here, so skip those. But then starting from the 3 with the bracket to positive infinity, I would also get a graph above the x-axis. All right, let's take a look at another one. What about x cubed plus x greater than or equal to 6 minus 4x squared? Well, same as before, let's move it all to one side, and I went ahead and put it in order just because it looks nicer. And if I'm going to try to sketch this myself, I would want to try to factor this, and it's always best to factor when it's, of course, in descending order. The problem is this doesn't factor, so I can't do it as quickly that way. I'm just going to go ahead and put this in my calculator. Here's my equation and standard window. I don't think that's my graph, is it? Yes, it is. Okay, so that is my graph right there. Okay, and I'm looking, remember that rational zeros theorem? Okay, it said factors of this last guy over factors of this first guy. Well, what are the factors of 6? 1, 2, 3, and 6. So if I were guessing what these numbers were, I could do this pretty quickly. Let's check. Is it negative 3? Yep. And then I bet that one's going to be negative 2. Yep. And then, of course, that one's going to be 1. I'll let you trust me on that. Okay, so if I'm looking here at my picture, I'm going to go ahead and look back on the screen. I've marked my zeros, and I asked, what am I looking for? I want it greater than or equal to 0, so that means above or on the x-axis. Well, it's just on and above, right in this little tiny interval from the negative 3 to negative 2, again with brackets, and then it drops below until I get to 1 to infinity. So bracket on 1 to infinity. One last example here. If I have a picture, f of x graphed for me, and they want me to determine where it's greater than or equal to 0, that means I'm looking for sections where it's above or on the x-axis. Okay, so I've got my zeros noted. It's not above here, but it is above here. Okay, so from negative 4 to 1, it's above the x-axis. I use the brackets because I want to include those endpoints. It falls below the x-axis, below, oh, it touches the x-axis, then falls back below. So I'm not going to get an interval, but I do want this distinct point here. So to show that, I put it in these little curly brackets. What if they want f of x to be less than 0, strictly less than 0? That means just strictly below the x-axis. Well, all of these points way back here are going to give me the picture below the x-axis. So from negative infinity to the negative 4. Skip this section. From the negative 1 up to the 3, we're below, but I don't want to include the 3, so just negative 1 to 3 with parentheses there. And then from the 3 forward, it's below again, so we kind of just notched out the 3. And then this last one, f of x less than or equal to the 0. Okay, well this time it can be below or on the x-axis. How does that change my answer? It's still going to be this back section, negative infinity to negative 4, but I'm going to include the negative 4 this time. Okay, I'm going to start here at negative 1 and include it with a bracket, and I can go all the way up here to 3 And this time I can include the 3, so I can just keep right on going to positive infinity. There's no reason to break this up here because all of this is going to give me something that's below or on the x-axis. So the second part of my answer there is the -1 to infinity.